For 1.5, we're going to be talking about inverses. We've already know inverses are basically opposites. So inverse of addition is subtraction, multiplication is division, square root is squared. You understand. Okay. So our inverse relation, remember we talked about that relation yesterday. This is the ordered pair is in a relation if and only if the ordered pair BA is in the inverse relation. Okay, so notice all that happened is that these points got switched. Okay, an inverse is the result of switching. I just said that. Inverse equations are found by switching. Hey, guess what? There's that switching again. And some inverses are functions and some are not. Okay, so the one we always go to is y equals x squared. Okay, we do this equation a lot because you know that it's a parabola, it's facing up. Okay. We know the inverse is also a square root function. Okay, and again, we've talked about how it actually needs that plus and minus the square root x. We will talk about how to get that. I think not until Monday. Okay. So the first one, we know this is a function, right? We've done parabolas lots of times. It always passes our vertical line test. We know the inverse is not a function because, oh, look, our vertical line test, it touches at 2 points. Okay. The inverse in B fails the vertical line test because the original fails a horizontal line test. Okay. So what that's saying is you don't have to graph the inverse. All you have to do is, if you have the original, is try a horizontal line test instead. Okay? If you think about it, it's just flipping your graph, so that makes sense. Okay? If it touches twice in a horizontal line test, like it does right here, okay, we know it is going to fail. Okay? So, horizontal line test. The inverse of the function is a function if and only if each horizontal line intersects a graph and the original relation in at most 1 point. Okay, you've done this. You know vertical line test. It's just turning your line. So which of the graphs, 1 through 4, are graphs of relations that are functions? Okay, so first we're going to look at the original. Okay, so for every single one of these, let's look at the original. Our first one, it does pass my vertical line test. So no matter where I draw the line, it's only touching at 1 point, no matter what it is. Even here, there's not going to be anything at that 0. That still means it's a function. Okay. Our second graph, oh, right away, it fails the original fails the vertical line test, so it is not a function. Okay, our third one is a circle. We have done this before, or I guess it's an ellipse or an oval. It's not a function, it fails. Okay, and our last one, okay, it will pass, so it is a function. Okay, now we're going to go through and look at the inverse of each of these. Okay, when we're looking at the inverse function, this is when we're doing the horizontal line test. So the first one passes, it's a function. Okay, the second one passes, it's a function. The third one fails, it is not a function. I'm hoping you guys have figured this out by now. Our last one, not a function. It is going to touch in multiple places. Okay, so just remember, vertical line test is for the original. Without regraphing, we can tell if the inverse will be a function by doing the horizontal line test. Okay, so A was talking about the relations that are functions. B is the relations that have inverses that are functions. So let's say this is 1, 2, 3, 4. The ones that are the originals are functions are 1 and 4. The relations that have inverses that are functions are 1 and 2. Okay, let's look at the next page. Based off of what we just did, the next step is our one-to-one functions. A one-to-one function is a function whose inverse is also a function is called one-to-one. So each x is paired with a unique y, and each y is paired with a unique x. Okay, so all that this means is that both the regular function, the original, and the inverse are functions. Okay, just heads up, inverse function we denote by using this -1 power. We've done this when we've worked with sine and cosine in the past. It was when you had to switch it to arc sine, arc cosine. Okay, that's where that -1 is kind of coming from. It does not represent a power. Okay, so don't let that confuse you. Just how we write it. Okay, f to the -1 of b is the inverse function of b equals a. That's only true if and only if the function of a equals b. Okay, so that one-to-one, real quick, before we move on past that, I just want to look at that previous page. The only graph that is one-to-one is this first one. 1-to-1. And that's exactly how we write it. We don't have to write it out. We just put 1-to-1. And that's because both of these are functions. Those don't match in any of the other ones. Okay, let's look at this algebraically. Okay, find an equation for f, the inverse of f of x, if the f of x equals x over x plus 1. So first thing I want to do is I'm going to rewrite this because I hate that type of fraction sign. So I'm going to say f of x equals x over x plus 1. Okay. Now, to figure out, our first step to do this is to rewrite this with a y. Okay, don't let that confuse you. So we're just y equals x over x plus 1. Okay. Then what I want you to do is switch your x and y's. So now I have x equals y over y plus 1. Okay. And your goal is to get this equation to say y equals. Okay. So I am going to first get rid of this fraction. I'm going to multiply both sides by y plus 1. Okay. On the left side, I will now have x times y plus 1. On the right side, I'll have y. My next thing I want to do is I think I'm going to distribute this x and y, or this x to xy plus x equals y. I just distributed. Okay, I'm getting closer. Remember, my goal is to have all my y's together. So since I have a y on this side, I am going to subtract xy over. Okay, and I'm going to have to move over a little bit. So now we are left with x equals y minus xy. Okay, now this could be a little confusing. However, since I have two y's, I can factor those out. Hopefully we remember factoring. I'm going to take out that y, and whatever is left over after I divide them. So y divided by y will be 1. Negative xy divided by y will be negative x. Okay. At this step, I can almost get y by itself. All I have to do is divide. So I am going to switch colors just so you can see that step very clearly. Okay. So now I have x over 1 minus x equals y. Okay. Or y equals x over 1 minus x. Okay. Very, very last step is to switch it. Since I started with f of x and I found the inverse, now I have f inverse of x equals x over 1 minus x. That is your inverse function. Okay, so let's write a few notes. Okay, so step 1, change f of x to y. Step 2, switch your x's and y's. Actually, there should only be one y. Step 3, solve for y. Okay. After you solve for y, change y to be your f inverse of x. Okay. This finding an inverse function algebraically is going to come back. Okay. And actually this exact solving process that we did is going to come back. So make sure you understand how I had to multiply, I had to distribute, then I had to factor, all of that just so I could get to my inverse. Okay. In fact, if I were so bold, I would maybe star this problem. Cough, cough, hint, hint. Okay, let's move on. It is possible to use the graph of f to produce the graph of f inverse without doing any algebra at all. However, this only really works when when I'm given a graph and it's a graph with nice points. Okay, this is because we were able to just flip the graph to find the inverse. Okay, so the graph of function y equals f of x is shown in this figure. Sketch a graph of the function y equals f inverse of x. Is f of f a one-to-one function? So right away, looking at this function, actually I'm going to write it in blue because that's the color of the graph. Is f of x a function? Yes, because it passes the vertical line test. Okay. Then let's look at our horizontal line test. Is it going to pass? Yes. Okay. That tells me right away that this is one-to-one. Okay. Now we just need to go graph the inverse. So what we're going to do is we're going to use our original, and I'm going to find some of the points. So right here, I know is 0, 1. If I move over, it looks like this is 1, 2. And it looks like right here, I have -1, 0. And then I'm not quite sure about other ones. Notice how that is reflected. So that makes sense to me. Okay. This will be plenty for us in order to get started, to figure out our graph. So if I have -1, 0, I know 0, -1 is the inverse function. I just switched those numbers. If 0, 1 was on the original function, 1, 0 is on the inverse function. Okay. And then if 1, 2 is on the function, 2, 1 is on the inverse function. Okay. Now, what I need you to be careful of is remembering that this graph is actually going to be flipped. Okay. So please, please, please do not do this. Do not draw the exact same thing, shift it over. Okay. Don't do that. Okay. We are going to draw the inverse of it. So it's going to connect and go this way. It's going to connect and go this way. It should look like it flips. Okay. It's kind of like it's turning. So we talked about two concepts of that one. One was vertical line test, horizontal line test, told us it was 1-to-1. The other was graphing or finding the points and then graphing those points as the reverse to find the inverse graph. Okay. At this point, I think that is plenty enough for what we are doing today. You guys can go ahead and get started on your 1.5 homework or work on any of the previous homework that if you haven't finished that. On Monday, we are going to finish the rest of 1.5.